Hello, and welcome to the video presentation of Predator versus Prey. Our group consists of Stephen Cates, Pamela Martin, Salahadin Ahmad, and Catherine Richardson. In this presentation, we will discuss the physiological eye adaptations in organisms. Predators and prey have diverse interactions, and within a habitat they will evolve together. As you can see, adaptations under these conditions include descent, speed, color, smell, and today we are talking about sight. Adaptation of sight includes differences in predator and prey visual fields. This visual field difference can be seen throughout many phyla. So you may wonder, what is a visual field? Visual field is all of the points of the physical environment that can be perceived by a stable eye at a given moment. A predator's visual field is different from that of prey. Generally, predators have larger eyes, forward-facing, and oriented at the front of the skull. Therefore, their visual fields are focused toward objects in front of the organism. This allows them to hone in on a specific object or target in front of them, ideal for hunting. You can see the field of vision from the diagram below. In contrast, prey eye location is different from that of a predator. Generally, their eyes are oriented more toward the sides or the top of the head. They have a wider field of vision and better peripheral vision. They are capable of seeing to the side and behind much better than forward eyes. This is ideal for awareness of surroundings and evading predators. This field of vision can be seen in the diagram below. Here are examples of predator and prey for phylum Chordata. The organisms show real predator-prey interactions found today. Based on eye orientation, which species would you think is predator and which is prey? As you can see, the rabbit's eye's orientation is localized on the sides of its skull, whereas the fox's eyes are oriented facing forward and more towards the center of the skull. There's a field of vision diagram below specifically for rabbits, showing their large scope of peripheral vision. Here are examples of predator and prey for phylum Arthropoda. To the left, you have Drosophila, or commonly known as the fruit fly. On the right, you have a praying mantis. Fruit flies are common prey for the praying mantis. Once again, you can see that the prey, or the fruit fly, eyes are oriented toward the side of the head, allowing for a wide scope of vision, whereas the praying mantis has eyes facing forward, much like the fox, which allows for a more focused and centralized scope of vision. Along with eye location, pupil shape varies based on predator-prey requirements. Usually you will see round or vertical pupils in predators and horizontal in prey. So what's the function of pupils? By variations in the amount of dilation, the pupil can control the amount of light let into the eye. This dilation is controlled by the sphincter pupilla used for pupil contraction and the dilator pupilla used for dilation. Dilation is controlled by the sympathetic nervous system, while the contraction is controlled by the parasympathetic nervous system. Here you can see that the parasympathetic pathway leads to constriction and the sympathetic nervous system leads to dilation. Therefore, their control is independent of one another. So a constricted circular pupil will shade the peripheral zone of the lens, leading to a loss of well-focused images at relevant wavelengths, whereas a slit pupil allows for the use of the full diameter of the lens, even in bright light. Here are some examples of prey pupil shape. A commonly seen horizontal pupil shape found here in Oklahoma is the goat. Also, the octopus can be a prey. As we discussed earlier, having eyes oriented on the side of the head allows you to have a better peripheral vision. This is also true for horizontally shaped pupils. This works much like a widescreen film or a panorama photo. Another common prey found in Oklahoma is the horse. This diagram demonstrates how huge a horse's peripheral vision truly is. The position of the eyes on the side of the head in conjunction with horizontal pupil shapes allows for almost 360-degree vision. Examples of vertical or round pupil are seen in vipers, cats, and falcons. All of these species are predators. These pupil shapes along with eye position give the predator a sort of tunnel vision, allowing the organism to fully utilize binocular vision in order to focus specifically on an object oriented in front of them, ideal for their hunting.